everyone. Welcome to today's session. My name is Anjali Nigam. Today is the first of the many sessions which we will be having on graph theory. But before getting into that, let me tell you something about myself. I'm an assistant professor in the engineering department. I have a degree in Masters in Technology in Computer Science. I am teaching since 5 years now. I have taught subjects like C, C++, Java, HTML, software testing, management information system, and networking. I do enjoy teaching a lot and especially computer languages. Now let's shift our focus back onto graph theory. In the upcoming sessions, you'll notice that it is a very interesting subject and it has applications in many different fields such as communications, networking, neurology, and so on. The first topic which we will be studying today is the history of graphs. We need to know how graph theory emerged as a subject and how it helps us to solve our real life problems. So the learning objective says that at the end of this session, you will be able to understand the history of graphs. We will study about who gave us the first theorem and on what problem was he working on and what were his conclusions after his given theory. So the first theorem was developed by Swiss mathematician Leonhard Euler in 1735 while working on the Königsberg bridge problem. I hope you can see the image on your screen. This picture belongs to Leonhard Euler, and he gave us the first theorem in 1735. He was a Swiss mathematician and he was working on the Königsberg bridge problem. We need to further study about Königsberg bridge problem and understand what it was all about. So the Königsberg bridge problem says that the city of Königsberg, which was in Prussia, had 7 bridges. So as you can see in the image that there are 7 bridges and surrounding the bridges, there are 4 land masses. One here, one in the middle, third here, and fourth at the other edge. So the problem was to devise a walk through the city that would cross each of those bridges once and only once. So what was the Königsberg bridge problem? It was that you have to devise a walk through the city. You have to walk around the city and you have to cross these bridges, but you have to cross these bridges only once. That is, you cannot repeat a path. It had an additional requirement that the trip ends in the same place it began. It means that your starting and ending point would be the same. That is, if you start your journey from this particular bridge, then you have to end your journey at this bridge only. You cannot end your journey at any other bridge. Now let's see what theory did Euler give on this particular problem. Euler proved that the walk of Königsberg Bridge is impossible. So while working on this problem, in the end, he proved that Königsberg Bridge problem is actually impossible. No one can cross all the bridges without repeating the path. And also you cannot just start and end your journey at the same bridge. But how he did that? For solving this problem, he divided the problem into 4 vertices and 7 edges. So as you can see, A, B, C, D are the 4 vertices and the edges are the 7 bridges which connects the 4 vertices. The bridges have been converted into edges and the land masses have been converted into vertices. The edges are connecting the vertices. He noted that a route is only possible if the given conditions are satisfied. In the end, he gave the theory that this problem can only be solved if the following conditions given by Euler were satisfied. Now, what were those conditions exactly? The first one was, if there are more than 2 areas to which an odd number of bridges lead, then such a journey is impossible. So his first point in the given theory was that if there are more than 2 areas to which an odd number of bridges lead, that is, if the number of bridges are 1 or 3 or 5 or 7 and it is connected by more than 2 land masses, then such a journey is simply impossible. You cannot walk on such a path. His second point was, if the number of bridges is odd for exactly 2 areas, then the journey is possible if it starts in either of those two areas. What his second point meant was that the land masses should be exactly two, not more than two, and it should be connected with odd number of bridges. That is, the bridges can either be one or three or five or seven and so on. But the land masses should exactly be two, not more than two. Then the journey is possible if it starts in either of these two areas. And you need to start those journey in either of those two land masses which are connected by the bridges. He gave the last point in his theory, which was if there are no areas to which an odd number of bridges lead, then the required journey can be accomplished starting from any area. If there are no land masses which are connected to odd number of bridges, again, the bridges can be in odd number, that is 1, 3, or 5, but there should not be any land masses attached to it, then the required journey can be accomplished. That means then the journey is possible starting from any area. Then you can start from any land masses which is around the bridges. So in this session, we discussed about the history of graphs. I hope you were able to understand about how Leonhard Euler worked on Königsberg Bridge problem in 1735 and how he proved that such a walk was simply impossible. So this was our first session about history of graphs. I hope it was clear to you. In the next session, we will be discussing about some basic terminologies which is used in graph theory. Those would be essential for you to understand the different concepts present in this subject. Once again, thank you very much for attending this session. And my name is Anjali Nina.